Percent of increase and decrease. First, let's do a little review. Remember that percent, if you break it down, per means divide. When I say miles per gallon, that's the miles divided by the gallons. When I say cost per pound, that is the cost divided by the pounds. Or cost per ounce is the cost divided by the ounces. So when you see the word per, think divide. Cent is Latin from centum, which means 100. Think of a century. A century is 100 years. So percent is a number divided by 100. And when we say 77%, that is in fact 77 divided by 100. And if you divide that out on a calculator, it's 0.77. 50% then is 50 divided by 100. And since the numerator and denominator are both divisible by 50, if I divide them both by 50, I get 1/2. 50% is 1/2. 25% is 25 over 100, and that would simplify or reduce to 1/4. 80% is 80 divided by 100, which would reduce to 8 over 10, or divide both by 2 would be 4/5. Keep in mind, all these fractions can be written as decimals. 1/2 is 0.5, or 0.50 if you like. 1/4 is 0.25, and 4/5 is 0.8. Now, make an observation here. In fact, since you're dividing by 100, all you do is move the decimal 2 places. So in 77%, the decimal is always at the end of a number if there is no decimal. Because you're dividing by 100, you're moving it 2 places. 50%, because you're dividing by 100, becomes 0.5, move it 2 places. 25%, because you're dividing by 100, move the decimal 2 places, it becomes 0.25. And 80%, move the decimal 2 places, becomes 0.8. When you're given a slope, like 35%, we can immediately know that that's 0.35. Keep in mind, you need to be able to go the other direction too. If I give you a decimal and say turn it into a percent, 0.42 is 42%. So if it's a percentage and I'm making it a decimal, I move it 2 places to the left. If it's a decimal and I'm making it a percentage, I move it 2 places to the right. And any of these can be turned into fractions. 35% is 35 divided by 100. Both of those are divisible by 5. That would be 7 over 20. 42% is 42 over 100. And both of those are divisible by 2. That would be 21 over 50. One of the ways we use percents is to talk about the increase or decrease in dollar amount or cents of an item. In fact, this calculation is done on every single thing in the store. Repeatedly, when the store buys them from a wholesaler, each item is marked up a percentage, and it's a different percent for different items. And in fact, when you buy them, they're marked up again because you pay sales tax around 8%. Things are increased a percentage. The first thing we want to do before we talk about that is how to simply find the percent of increase or decrease. What it is the amount of change, the amount the price changes, divided by the original. That means it's the new price minus the original price divided by the original. So if you were buying something that was $10, but today it was on sale for $8, the amount of change would be 8, the new, minus 10 over the original, which was 10. Now, notice this is -2. That's because the price decreased. Decreased. Divided by 10. And 2 divided by 10 is 0.2. This is -0.2 or -20%. In other words, it went down 20% in cost. So all we do is we subtract the new minus the original. That's the amount of change, how much the price changed, and always divide it by the original. You're always comparing to the original. One more example. If you went into the store and you were buying a shirt and it was $25 and it was on sale again, it was on sale for $22. So just like I did, I take the new price minus the old price, subtract, and divide by the original, which was 25. This would be -3 over 25, which ends up being, when you divide it on a calculator, 3 divided by 25 is -0.12. So that is -12%, meaning the price is going down 12%. Another way to look at this formula is new price equals original price plus or minus, that's if you're increasing or decreasing, plus or minus a percent of the original price. Now we mean multiply right here. So we'll shorten this to new equals original plus or minus a percent of the original. Now I want to point out this is exactly the same formula that's on the previous page. It doesn't look the same, but it is. Treat that percent like an x. Imagine if you were solving for x trying to get it by itself. The first thing you would do is subtract the original, and you would have new minus the original equals plus or minus a percent of the original. And then the last thing you would do is to solve for this, the percent, get it by itself, is you would divide both sides by the original. And then you would see that the percent, which is either an increase or a decrease, is the new minus the original divided by the original. And you see it's the same formula. It just looks different up here. But this form is actually more of how we think of percents when we buy and sell things or when they're on sale. Let's take a look at some examples. Every time you go to the store, let's say you're going to buy something that costs $10. You get a new price by taking the original, which is $10, and adding tax to it. Tax is roughly 8%. Remember that 8% is 8 over 100, which is 0.08. Do not confuse that with 80%, which is 0.80 or 0.8. They're very different. New equals the original 10 plus, because the sales tax increases the price, 8%, 0.08, times the original, $10. So I punch this in the calculator, and it ends up being $10.80. So every time you buy something, whatever you buy gets increased by a percent of whatever you're buying. This is the way it works. So if you go up to the cash register and you're buying something for $40, then your new price will be $40 plus 8% of $40. Which ends up being $43.20. But this formula can work different ways. For example, let's say you're buying something that was like a computer that was $899, but it was 30% off, special today. So you get a new price by taking the original $899 and it's going to subtract because the price is going to go down. 30% is 0.3 or 0.30 times the original $899. And then you just punch that in your calculator. And you see that it is $629.30. Now, in general, I want you to keep in mind when we're working with money right there, you need to round to the nearest penny. That's the way it works. So if you get a decimal like 0.335, you're going to turn that into 0.34 when you round. If you get a decimal like 0.621, you're going to turn that into 0.62 when you round. We're always looking for pennies. That's 34 cents. That's 62 cents. If it's 5 or bigger, we go up. If it's 1, 4 or less, then we keep it the same. Here's some examples from your assignment. Convert 2% to a decimal. Remember that 2% is 2 over 100, which is 0.02. Also keep in mind that when you say 2% and there is no decimal, the decimal is at the end of a number. Any number at all I give you. If I say 75, that's 75.0. So 2%, when I move, because I'm dividing by 100, moves the decimal 2 places. That's why it's 0.02. That might help you on the next one, which is 0.4%. 0.4% is 0.4 divided by 100. Now you can do that on the calculator. It will spit out 0.004. But keep in mind, 0.4%, when you move the decimal 1, 2 places, is 0.004. %374% is 374 divided by 100, which is 3.74. So while we're at it, remember that 100% is 100 over 100, which is 1. So 1 is 100%, and then 2 is in fact 200%, and 3 is 300%, and so on. The decimal 0.64 is equivalent to what percent? Well, 0.64 is 64 100ths, 64 over 100, which is 64%. This time we're moving the decimal 2 places the other direction to make it 64.0. 64%. The fraction 1/5 is equivalent to what percent? Well, there's an easy way to do this on the calculator. You can just take 1 divided by 5, and it will spit out 0.2. And at that point, you've got to realize, well, 0.2 is 20% because I'm moving the decimal 1, 2 places. But you could also do it this way. You could say, hey, 1 over 5, if I'm going to make it a percent, it's going to be over 100. I could call that x, and I could cross multiply. 5 times x is 5x. 1 times 100 is 100. Divide by 5. I see that x would be 20. So it's 20%. Dividing on the calculator is the quick way. 40% is equivalent to what fraction in reduced terms? 40% is 40 over 100, which is 4 over 10, and they're both even. Divide them both by 2 is 2 over 5. So in simplest form, it's 2/5. Here we have a percent of change. Remember that percent of change is the amount of change divided by the original. So we subtract them. So we take the new 91.8 minus 90 and divide by the original 90. Now when you do this on the calculator, you're going to need parentheses up top. Otherwise, it may divide first because the order of operations would tell you to divide first. But 91.8 minus 90 ends up being 1.8 divided by 90. And 1.8 divided by 90 is 0.02. So what percent is that? Well, that would be 2%. If a quantity changes from 25 to 15, well, by the way, on the last one, notice how it was an increase. This is an increase, in case they ask that in the future. This one is a decrease. But just like the last one, we find the amount of change. So the new 15 minus 25 divided by the original 25, well, that would be negative 10 over 25. The negative just means it's decreasing, and that ends up being negative 0.4, which ends up being a 40% decrease. But negative is not part of the answer. It just tells you that it's decreasing, that it's a percent of decrease. An electronics store has reduced the price of a TV from $1,200 to $1,104. So I'll take the new price, $1,104, minus the original, $1,200, and divide it by the original, $1,200. And I'll just punch that in the calculator and get a decimal. That ends up being negative 0.08. The negative just tells us it's a decrease. So what percent is that? Well, that would be 8%. The table sells for $317. However, this weekend it's on sale for $199.71. So I'll take the new price, $199.71, subtract the original price, $317, and divide it by the original $317. That ends up being negative 0.37. And the discount then is 37%. A shirt was originally priced at $80. The store is having a 10% off sale. So I'm going to get a new price by taking the original, and it's a sale, so it will decrease the price by a percent of the original. So my new price is going to be by taking 80 subtracting 10% of 80. So I punch this in the calculator and I get 72. So $72 is what it would be. That's the price of the shirt after the discount. Here's a shirt that was $75 and it's having a 40% off sale. So I'll get a new price by taking the original and subtracting, because what's going to be a percent off, percent of the original. So my new price I'll get by taking 75, subtracting 0.40 or 0.4 times 75. Punch that in the calculator, and I get $45. Use the information to find the new price. Round to the nearest cent. So I'm going to find a new price by taking the original. It's a discount. Now it could be a markup. If it was a markup, we'd be adding, but it's a discount, so we're subtracting. We're going to take the original and subtract a percent of the original. So that would be $24 minus 0.16 times $24. And we get $20.16. Use the information to find the new price. So I'm going to take my original 24, and this time I'm going to subtract 22% of $24. It's exactly like the last one, just different numbers. A different percent is actual, the only difference. So that ends up being $18.72. Here we have an increase. So tuition at the college is $2,300. So we're going to get a new price for tuition by taking the original, and because it's an increase, it will add a percent of the original. So the new price will be $2,300 plus 6%, that's 0.06, not 0.6, times 2,300. And that ends up being $2,438.00. If a woman making $32,000 a year receives a cost of living increase of 2.1%, what will her salary be? So she's going to get a new salary by taking the original, and it's an increase, so it'll be plus a percent of the original. So the original is 32,000 plus 0.021. Remember that 2% is 0.02. 2.1% then is 0.02, the same, but a 1 after. So I need my original again, 32,000, and punch that in the calculator. Her new salary will be $32,672. In the state of Washington, there's a shortage of math teachers, and the number keeps dropping 3% each year. If there are currently 16,000 math teachers in the state, how many will there be next year? So we're going to take our original 16,000 and we're going to decrease it 3% of 16,000. Same formula. We're getting a new price by taking the original and decreasing, because it's going down, 3% of the original. Punch that in the calculator, and the result is 15,520 teachers, math teachers. Last few examples. The U.S. Weather Bureau has a station on Mauna Loa in Hawaii that has measured carbon dioxide levels since 1959. At that time, there were 322 parts per million of carbon dioxide in the atmosphere. In 2005, there were 382 parts per million. Find the increase in carbon monoxide levels and the percent of increase. So we're looking at two numbers here, 382 and 322. Subtracting those two, we get 60. So we know that percent of change is the amount of change, how much it changes, subtract, divided by the original. So we'll take that 60 and we'll divide it by the original, which was 322. 60 divided by 322 ends up being, we have to round here. It would have been nice if they told us what to round to, but I got 0.1863335 and so on. I would probably round to the nearest percent, so that would be 19%. The 6 tells us to go up. In one day, the stock for Warbucks coffee rose from 50 to 59 a share. What percent did the stock rise? So we're back to this formula. The amount of change, that's 59 minus 50, divided by the original, 50. So that's 9 divided by 50, which ends up being 0.18. So that would be about 18% then. The price of a greeting card rose from 35% to $2.70 over the past 20 years. What kind of increase is that? That's a lot. So we're basically going from 35 cents to 270 cents. $2.70 is, we have to have it in the same kind of unit, is 270 pennies. So we subtract the two, new minus original, that's 270 minus 35, and then we divide by the original 35. That ends up being 6.71428 and so on. Now, as a percent, 1 is 100%, 2 is 200, 3 is 300, 6 is 600. This is 671%. Now, it says round to the nearest tenth of a percent, so I suppose we'd say 671.4. Now, if we're going to round right there, we've got to look at the 2, and the 2 would have us keep it the same.